In this video, you will learn about a theorem involving right angles. So what I'd like you to start by doing is answer the first two questions, and then based on your responses to these first two questions, I want you to see if you can derive the theorem relating right angles. So go ahead, pause the video, answer questions 1 and 2, and then see if you can write out this next theorem. Press play when you're ready. Okay, so here are two examples of diagrams you could have drawn for number 1, when it says draw two angles that are both supplementary and congruent. So hopefully what you noticed about your two angles that you drew is that they both have to be right angles. So in order for two angles to be both supplementary, so add to 180 degrees, and be congruent, they have to be right angles. So that leads us into our theorem from this section. And that theorem says if two angles are both supplementary and congruent, then they are right angles. So let's try to use this new theorem to attempt this proof in example 1. So in example 1, it asks us to prove that the median to the base of an isosceles triangle is also in altitude to that base. Okay, so we've already kind of talked about this idea in previous sections, and we already kind of know this relationship. But now, this theorem comes into play for actually proving why this is the case. So first we're going to have to draw the diagram, label it, and then set up this proof, just like we did in the previous section. So I'm going to have you go ahead and do that, get this proof all set up, and then we'll kind of walk through this proof together. So you can go ahead and pause the video while you're setting it up, and then press play. Okay, so take a look at your diagram. Hopefully you have something similar to mine. Maybe not all the letters are the same, but you should have about two givens. One of your givens should say that the triangle is isosceles with base, and you also need to say that there is a median, and then you're trying to prove that that same median is an altitude. So I feel that you should be able to get through these first 6 steps based on everything you've already learned. You should be able to prove that those two triangles are congruent, and you're going to need to do that in order to prove that it's also an altitude. So since it's isosceles, and again, this is just one way of completing this proof, there are other ways. You can also prove the two triangles by SAS. I chose to prove it by SSS. So I said if isosceles, then the two sides are congruent. Then if it's a median, it divides the side opposite it into two congruent segments. I used the reflexive property on BD, and then I proved the two triangles were congruent by SSS. So you should be able to get to this point. Okay, now we need to think about how do we prove that's an altitude once we know that the two triangles are congruent. Well, let's think about that new theorem. That new theorem says that if two angles are both supplementary and congruent, then they must be right angles. So which two angles on the diagram could we prove are right angles? We can now prove that angle BDA and angle BDC are right angles. So I'm going to call those angles 1 and 2. First, we can now prove them congruent. We needed to prove the triangles congruent in order to prove those two angles congruent. So let's prove them congruent first. So we're going to say angle 1 is congruent to angle 2 by CPCTC, since we've already proven that those two triangles are congruent to each other. And now that we have these two angles congruent by CPCTC, normally the next step would be to say that they are supplementary. But you will notice at this point in the textbook, they no longer include supplementary as a step in their proofs. They let you kind of just assume that, or the reader just kind of assume that. They don't actually write it anymore in our two-column proofs. So from this point on, you no longer need to say that two angles are supplementary in your proof, just like you no longer need to say that an angle is a straight angle. So now we can just go straight to saying that since we know they're congruent and we know they're supplementary just from looking at that diagram, Now we can go straight to saying that angles 1 and 2 are right angles by our new theorem. If two angles are supplementary and congruent, then they are right angles. And now that we know those two angles are right angles, we can reach our final conclusion, which was that BD is an altitude of the triangle. For this would be if a segment drawn from the vertex of a triangle forms right angles with the opposite side, then it is an altitude. Okay, so hopefully really the only new step that we've learned is step 8. Everything else should just be review for you. Step 8 is the only place where we had to prove right angles. So anytime you're trying to prove that something's an altitude or perpendicular or anything that has to do with forming right angles, that's when you would use this new theorem. So I'd like you to pause the video here and try example 2 on your own, and then press play to check your answers, and we'll just talk about some of the key components that you should make sure you have in your proof. So pause the video here, try example 2, and when you're ready, press play. Example 2, we're given that angle Y is congruent to angle C, and ray XR bisects angle YXZ. And ultimately we want to prove that segments XR and YC are perpendicular to each other. So the only way that we can do this, if we work a little bit backwards from that proof statement, would be if angles 3 and 4 are right angles. And I know that the only way that I'm going to be able to get those two angles to become right angles is to first prove the triangle's congruent. So I started off my proof by copying down my given that angle Y is congruent to angle Z. From there, I knew that I could say that YX is congruent to XZ because if two angles in a triangle are congruent, then the sides across from them are also going to be congruent. So now I already have an angle and a side. Then my second given, ray XR bisects angle YXZ. From there, after I copied down that given, I said that angles 1 and 2 are congruent because if a ray bisects an angle, then it divides it into two congruent angles. So from there, I had enough information to prove that triangle XYR is congruent to triangle XZR by angle, side, angle, steps 1, 2, and 4. Now that I've reached that point, I can say that angles 3 and 4 are congruent by CPCTC, and now I can use my new theorem in step 7 that says angle 3 and angle 4 are right angles, because if two angles are both supplementary and congruent, then they must be right. And then finally, my last step is to say that those two segments are perpendicular, because if segments form right angles, then they are perpendicular. So hopefully now you have a better understanding of when to use this new theorem about right angles. Look for those keywords such as perpendicular, altitude, anything that indicates right angles is when you're going to need to use this new theorem in a 2-column proof.